Well, hello everyone. Today is Monday, September the 8th, 2025, and my name is Brettschneider. I'm a senior forecaster and senior climate scientist with the National Weather Service Alaska region. And we've got all the data in for our summer 2025, and we're going to look at how we did across the state and some indications of where we might be looking for the next couple of months and for the fall. So we got a lot of slides, so let's get right to it. And a couple of highlights. Let me get fully off the camera here. So some of the big highlights this summer was the Mendenhall River flood in August. It was the largest of the glacial lake outburst floods that we've been having for the last 14 or so years. Record stage, over 16 and a half feet. But thankfully, those HESCO barriers, for the most part, minimize the damage potential. If you remember back to June, we had some significant snowmelt and breakup flooding along the North Slope. Some of the rivers there had their latest breakup on record, and the Dalton Highway was closed for flooding. Some statewide, this is the 11th time in the last 12 years we've had an above average summer rainfall total. And just over 1 million acres burned statewide. That's higher than the long-term average, but it's not an exceptional number. So those are some of the highlights. And if we look at records, I'm not sure how readable this is, but this shows a list of how many high max, so high temperatures, low max, high min, so that's warm overnight temperatures, low max, so that's record cool high temperatures, and then low min, which would be record low temperatures, and then record daily precipitation events. And as you can see, we have almost every place had some number of record high minimums, so warm overnight lows, high maxes, and not a lot of entries here in the blue columns. And then quite a number of places had daily record rainfall rates. I did do a strike through of Yakutat down here. They did have a thermometer problem this summer that was reading too warm. So this really is an inflated number. So let's review how our sea ice did for the summer months. And this is kind of how we started. I couldn't find the June 1st plot, but here's the June 2nd plot. So the Chukchi Sea was essentially all full of ice. The Beaufort Sea was full of ice, and we even had a little bit of sea ice here, between St. Lawrence and St. Matthew Island. And here's how we ended up. And now you can see not a lot of ice in the Chukchi Sea, a little bit more in the Beaufort Sea. But importantly, for the time of the year, the Chukchi Sea is actually doing quite well. And the Beaufort Sea is doing exactly the average amount for the previous 20 years. So historically, these are low numbers, but for the recent past, these numbers are between okay and pretty good. So if we look at the daily temperatures each day throughout the entire summer period, you can see the highs and lows. So we started the first 10 or 12 days of June quite cold. A lot of snow even in the northern part of the state. And then we went pretty warm all the way through about through the end of the first week of July. And then we kind of bounced up and down. And the end of July, first third of August, we were pretty warm. And then we've kind of bounced up and down a little bit. And if you add up all these numbers, I think 24 of the days were in some shade of blue and 68 days were in some shade of red. So exactly twice as many days were warmer than normal than were cooler than normal. Okay, so how does this translate into a map? Well, this is using station data. And like I said before, station data is pretty good for temperatures, but you have to remember there's lots of data gaps in here, especially in the western part of the state and the northeastern part of the state. So anything kind of north of Fairbanks and west of Fairbanks, a lot of open spaces. But using our station data, we can see that the average statewide temperature about 0.6 of a degree above normal, kind of coolish. in most of the Kuskokwim River Basin and above normal pretty much everywhere else. All of Southeast, all of the central and northern interior, North Slope, Copper River Basin, here in Anchorage, just a tad below normal. But it was, otherwise not super remarkable. Even the places that were a little bit above and a little bit below normal, we would actually consider that to be near normal. If we look at some of the individual stations, so I'm going to look at Anchorage, Juneau, and Fairbanks separately. So our average summer temperature, the 2025 average was 57.3, and the 1991 to 2020 normal, 57.8. So about a half a degree cooler than average for Anchorage. Okay. How about Juneau? Juneau time series this year was 56.1. I'm sorry, 56.5. And the 1991 to 2020 normal is 56.1. So about 0.4 of a degree warmer than normal. But really look at this from when the airport data starts from 1944, for the first 30 years, this would have been the warmest year on record in Juneau. So if it felt kind of cool and damp and not very summer-like in Juneau, remember this would have been, again, the warmest summer on record prior to the mid-1970s. And then finally, Fairbanks. So Fairbanks, this summer, 60.9 degrees, and the normal, the black line, 60.2, so about 0.7 of a degree Fahrenheit above normal. And similarly, now we're starting 1930 here, between 1930 and, the late 1960s, this would have been the second warmest summer on record in Fairbanks. So just this relentless gradual increase in our summertime temperatures. Okay, so now let's look at precipitation. Precipitation is really problematic in that these missing data points can make a huge difference in how this station-based map looks. But statewide, our average, 108% of normal. So normal would be 100%. So a little bit wetter than normal. And the southern part of the state, and then southeast was, I'm having trouble pointing here, at or below normal for precipitation. The central part of the interior, say, just north of the Alaska Range to, just near the Yukon River was kind of near normal. And then north of the Yukon River, all the way up into the North Slope was wetter than normal. And that includes pretty much all of the West Coast from Bethel to Nome to Kotzebue. So you add all that together and it's 108% of normal. Now, one of the things that's a little tricky is because Southeast Alaska, their precipitation totals are higher, they can have an outsized influence on the statewide average. The Juneau Weather Service forecast area, even though it's like 10 times smaller than the Fairbanks forecast area, gets about a third as much precipitation. And once again, let's look at a couple of precipitation charts for the big cities. And in Anchorage, the total was 4.41 inches, whereas the normal is 5.76 inches. So about 3/4, maybe 80% of the normal precipitation. And as someone living in Anchorage, I can attest, I think most people can, that it just didn't seem to rain as much this year as it did the previous years. And you can see the 3 previous summers were quite wet in Anchorage. Juneau had, I think I actually got these backwards. Juneau actually had 14.24 inches in 2025, and the normal is 15.36. Sorry about that. So Juneau was a little bit drier than normal for the summer period overall, but not too distant from what we normally expect. And you can see there's been quite the run of wet, really wet summers in the last 20 years. And so all things considered, not that bad. And then finally, Fairbanks. Fairbanks had 5.36 inches in 2025. Normal is 5.83 inches. And so about 92% of normal, I believe. So pretty much spot on for what we expect in Fairbanks, precipitation-wise, over the course of this summer. All right, so now, like we mentioned before, but I'll go over again, we use this data assimilation, data collection and modeling technique called Reanalysis, and it helps us fill in the gaps. It's like using the most fancy weather models we have, and every day, actually 4 times a day, we enter in new data, and it kind of projects what it thinks happened in between all of the points, the data points. So it's really helpful and quite accurate, not perfect, but really, really, really good. Okay, so what did Reanalysis think we did for our summer temperatures? Well, came up with pretty much the same number, about 0.8 of a degree warmer than normal, with the only below normal areas, and that's very, very slightly below normal in parts of the Kuskokwim River Basin, around Bethel, down, kind of toward Dillingham. Pretty much everyone else was very, very close to normal or warmer than normal. So overall, this was basically a warmer than normal summer for nearly everyone. If it wasn't warmer than normal, it was pretty much near normal. And how's that compare to recent years? We're kind of right on this warming trend line. The dashed line is an 86-year trend. And this year's statewide average temperature, again, for the first, pre-1970, this would have been the warmest summer on record. So by recent standards, it's kind of right in the middle of where we've been for the last 20, 25 years. But again, historically, a quite warm summer. And if we look at our running 12-month average temperature, we really, really peaked here in 2019, 2015 to 2019. We kind of, the fever broke a little bit for a couple of years, and now we're working our way back up again. So our current 12-month running average temperature is about -2 C here, so about 29 degrees Fahrenheit, similar to what we had in about 2002, but again, much warmer than we had anything historically. And how does that trend, that trend look like in map terms? Well, here's how we've done summer-wise over the last 75 years, so 1951 to 2025, and you don't see any blue on this map, right? Every place looks like is in at least this yellow. So every place has warmed. The trend has warmed by at least 1.5 degrees, and in many cases, quite a bit more than that, especially in the mountains here of Southeast Alaska, and then the Bering Sea, Chukchi Sea area that is strongly reflective of reduction in June sea ice. So this is kind of dominated by June, but this is an overall increase in all the summer months. Okay, now we've looked at temperature. How about we look at precipitation? The station-based precipitation, remember, showed 108% of normal. Now we're looking at 112% of normal, so it's generally telling the same story. Any place really in a line from Anchorage to Fairbanks and southeastward was drier than normal, at or drier than normal, and every place north and west of that line, pretty much everywhere, was wetter than normal, and in a lot of cases, much wetter than normal. Some of these areas from Unalakleet to Nome to Kotzebue, it's in this 150% above normal. Even some of this darkest green, 175% above normal. So really, really a lot of wet, a lot of rain in that area. And that's been the trend for the last dozen or so years in particular, it's been very, very wet. Remember I said earlier, 11 of the last 12 years statewide have been wetter than normal. And you can, for the summer, and you can see this. Here's our summer precipitation. Other than 2019, I think our long-term normal is 10.3, so about right here. And so, all these years since 2014, including this year, with the exception of 2019, have all been wetter than normal. So that's kind of a new normal for precipitation. And if you look at this running 12-month combined precipitation, look how we are just stuck now in this high precipitation range, this historically high precipitation range. We kind of briefly touched that in early 1996, but now that all-time record in 1996 is kind of the normal for the last couple of years. So just a really impressive change in the precipitation pattern. I wouldn't call it a regime shift just yet. We'd really like to see that last for a good 10 years before saying that's kind of a newish normal, but it certainly is a short-term normal. And just like with temperatures, here's our precipitation trend map. And over the last 75 years in the summer months, a modest but not insignificant increase in precipitation by over 6% statewide, but really strongly positive precipitation trends all the way from Anchorage, Prince William Sound, all the way really through all of Southeast, and then all of the North Slope as well. And really only some of these coastal areas, from Bethel to Dillingham to King Salmon, and then some of the Alaska Peninsula and eastern Aleutians have any hint of a drying signal. Pretty much everyone else is near normal or near flat to positive trend and changes of precipitation in summer months over the last 75 years. Okay, what about snowfall? Again, we don't usually think about snowfall in the summer, but particularly in the month of June, snow is a frequent part of the climatology. And you can see in the North Slope in particular, a lot of snow fell in the month of June. And because June was so cool, it really delayed the breakup. Well, the melt off of the snow and the breakup, and it caused rivers region-wide to kind of, on average, have about 25 plus year recurrence interval flows once that all melted real quick. And then a lot of these purples in the Alaska Range and the Chugach Range. Again, a lot of early summer snow. You could see it here in the mountains outside of Anchorage. The first 10 days of June, there was a couple of really substantial snowfalls that fell in the Chugach. Our long-term trend for snowfall for the summer months, it is a decreasing trend for sure, by a lot. But this year we kind of broke that trend. And this year's amount statewide was about the long-term average, but pretty high above the recent near-term average. How we do for clouds? One of the fixtures of summer, late summer particularly, and fall in Alaska is the persistence of clouds. This summer, not too terrible. Clouds it was a little bit less cloudy than normal by 1%. It's not a lot, but it's better than being on the plus side, right? So having a little fewer clouds, even with the higher amount of precipitation, probably made it seem a little more tolerable at times. The green is kind of near normal for clouds. The first shade of tan or light yellow means a little bit less clouds than normal, and any shade of gray, like around Anchorage, Talkeetna, the YK area, means a little bit more clouds than normal. And how about wind? Wind statewide for the summer months, about average. But as is common with all these variables, it varies across space, right? So the North Slope and offshore was less windy than normal. The northern Gulf Coast, less windy than normal, but the western part of the state was definitely windier than normal, by over a mile per hour. I mean, that sounds like a lot, but it adds up over a 92-day period, a mile per hour per day. That's a lot. And then offshore, especially over here, around St. Matthew Island, it was especially windy. Now, winds over the waters are always a lot stronger than they are over land. So as a function of, say, a percentage, a standardized departure, not very different here, than it was over here, but from a miles per hour amount, it definitely was different. And then the dew point, we talk about humidity a lot. Relative humidity, is dependent on the temperature. So really a better measure of the amount of moisture in the air is the surface dew point, which we measure in Fahrenheit. And we were about 0.4 of a degree above normal on average. So this gray is kind of near average. The green areas are where it was a little bit moisture, had more moisture than normal at the surface. And the tan and orange areas was where there was a little less moisture at the surface. So if it felt more humid in the northern interior, that's why. If it felt a little less humid than normal in south central, that's why. Now also notice that this 0.4 dew point increase is less than the 0.8 temperature departure. And so the net effect is the relative humidity was a little bit lower, but we don't really concern ourselves so much with the relative humidity at the surface. This is a much better reflection of what the surface conditions are like. But if we do go ahead and characterize humidity, which matters particularly in terms of fire activity, because fires really get started and flare up in low relative humidity environments. And overall, for the relative humidity for the summer, some of this area from Fairbanks and then a little bit southeastward was lower than normal. So that really helped out the fires. In south central, it was lower than normal. Most other areas, it was either at this white or green, slightly more humid than is typical for the most recent climate normal period. And sea surface temperatures, this one's a little bit tricky because it looks like, man, we're surrounded by cold water. Well, this is kind of dominated by the early part of the summer when we held onto our ice extra long, and that kept the sea surface temperatures cooler. And then when it did melt, and it melted later than normal, it meant that we had a delay in starting the warming of those waters. Here now at the end of the summer, now in the beginning of the fall, all these are warmer than normal. Okay, so if you were to look at just kind of a snapshot of what sea surface temperatures look like today, here in September the 8th, you would see that pretty much every place is above normal. But collectively for the summer, we ended up with cooler than normal sea surface temperatures in the Bering and Chukchi, but warmer than normal in the Gulf of Alaska. And then finally, looking ahead toward the next season, temperatures, how have they looked over the last 75 years for the fall season? This is where things have really, really, really changed in Alaska. So on average, any given location has warmed by over 4 degrees Fahrenheit in that time. But you can't read it, but these have 1 degree contours. And here on the North Slope, it's like 11, 12, 13 degrees. I mean, just really remarkable warming and extending down the western part of the North Slope at the west coast down to the Seward Peninsula. This is strongly driven by changes in summer sea ice. So historically, it used to be, sea ice in the summer, it retreated away from the North Slope by 100 miles. Well, now it retreats away by, 400 or 500 miles in many cases. And it takes a long time for that ice edge to make its way to the coast. So much of the fall now, the coast is ice-free, whereas historically it was only ice-free a very small part of the fall. And so when you don't have ice on that water, it's liberating heat to the atmosphere 24/7. If it's ice covered, it's like having a lid on it. Okay? No heat is escaping from the water to the atmosphere. So this has a local, a regional, and a global effect. But every place in Alaska has warmed substantially in the fall. This is also due to the later onset of the winter snowpack. So when we have snow on the ground, it's like having a mirror on the ground as far as solar energy goes. Hits that snow, bounces off into space, it's like it never happened. Now, let's say you're delaying the winter snowpack by 2 weeks, which is half a month, which is 1/6 this period. The sunlight is hitting the ground and is being absorbed and warming the ground. So a tremendous difference in the energy budget of an area, snow versus no snow on the ground. And then precipitation for the fall, look at that. We are increasing by 12%. And Southeast Alaska is mainly gray and a few dots of yellow, but everywhere else, fall precipitation has increased dramatically. This also is largely driven by changes in Arctic sea ice. Remember we talked about ice on the water acts like a lid to the liberation of heat. Well, ice in the water also acts like a lid on the liberation of moisture to the atmosphere. And so having all this excess reservoir of moisture in the atmosphere means we can get a lot more precipitation in the fall. It's also warmer now in the fall, which means the air can hold more moisture, which means you can have larger amounts of precipitation. So big increase in temperature, big increase in precipitation in the fall months. And I don't have a map of it here, but a big decrease in the amount of snow in the fall months. So that's kind of the definite new normal for fall in Alaska. All right, well, that's what I've got. Thanks for bearing with me this entire time. If you have any questions, don't hesitate to reach out to myself directly or to anyone at the Alaska National Weather Service office, and we'd be happy to help out, provide explanation, provide graphics, and so on. Also, don't hesitate to drop a comment here below, like and subscribe. Make sure you get all the notifications for new videos that we post. Thank you very much. Have a great day.